Welcome to part 3 of limits at infinity. In this video we're going to talk about specifically limits with radicals, that is, limits at infinity where the expression we're taking the limit of has square roots. So let's begin with this example. We have the limit as x approaches infinity of this expression. Note that we have a radical in the numerator. So what can we do in this case? We're going to do something very similar to our basic technique. Remember that in our basic technique we look at the greatest exponent in our expression and we divide everything by x to the n where n is the greatest exponent. So in this case we're going to work only on the radical. We're going to divide and multiply everything inside the radical by x squared, and it looks like this. We divide it by x squared and multiply it by x squared, so the expression remains the same. Now this factor here we can separate like this. So we have this expression now, and we had two cases to consider. First is when x is negative. Why do we have to consider two separate cases? Well, because when we take the square root, we need to take the positive square root. So the sign of x squared, of the square root of x squared, depends on the sign of x. Well, in this case, when x is negative and we're taking a positive square root, we can take this x squared outside the square root, and the positive square root is minus x, because as x is negative, minus x is positive. So here in this case we can take the negative outside the limit and take the x in the denominator here. So we have this expression, and we can write this like this. And now this is easy to solve because anything that is divided by x will go to 0 as x approaches infinity. So note that here in this case we're taking the limit when x approaches positive infinity, because we consider that x is positive. So in this case these terms go to 0 and this term goes to 0, so we have this expression here, and the positive square root of 1 is 1, so the final answer is minus 1. So in this case the limit is minus 1. Now let's consider the second case where x is positive. This case is easier because the square root of x squared will be simply x, because x is positive. So we do something very similar as in the previous case. We take the x down here and we write this denominator like this. Now everything that is divided by x will go to 0, this term here and this term here, so the final answer is 1. So the real final answer now is the limit is 1 when x approaches positive infinity, and the limit is minus 1 when x approaches negative infinity. And we can see this fact in the graph of this function. We can see that when x approaches positive infinity, the function approaches 1. And when x approaches negative infinity, the function approaches minus 1. So let's do another example. Let's now consider this limit here. Well, this limit may look strange because we don't have a fraction, we don't have a denominator here. So this limit is different, but it is quite easy to solve because we only need to divide and multiply by the conjugate of this expression. What is the conjugate of this expression? It's the same expression, but with the sign here positive instead of negative. So we multiply and divide by this expression. And doing the algebra in the numerator, we see you will get that you have this difference of squares. So now it's quite easy, because this square root squared is just x squared plus 1 minus x squared plus 1, and the 2x squared cancel out, and we have this expression. Now here we have two terms in the denominator that will approach infinity. This term will approach infinity, and this term will approach infinity also. So infinity plus infinity will also approach infinity. So the fraction itself will approach 0, because the denominator approaches infinity. So the limit is 0, and that's the final answer. That's all for now. Thank you for watching, and see you next time.